So I have created this file and whatever we did in IPython console, I copied all those commands over here. So there's nothing new here. Let me show you the output of this. Okay, so this is where we left off in the previous video, and this is the graph that we were getting. Now we will continue from here. After having created the network, we have to assign people to the nodes. So as I explained, we have to assign people of two kinds, people of type 1, people of type 2, and there'll be some nodes which will be empty. Okay, so what we can do is we can make use of package random. So I'll write import random. In order to assign people to nodes, what we can do here is that we can assign an attribute that is type to every node in the network. So this attribute type will have values from 0, 1 or 2. If the type is equal to 0, the node will be considered empty. If the type is equal to 1, the node will be considered a person of type 1. If the type is equal to 2, the node will be considered a person of type 2. So we will be following this convention. Let me assign the type to the nodes. So what we can do is for n in g dot nodes, g dot node, so we have to assign a type to n. So I'll write type. I want to assign a type randomly, so I'll write random dot rand int, and this should go from 0 to 2. So 0, 1, 2, any random value could be assigned to the type of to the type of node n. Now, after we have assigned the type to every node, we should maintain a list of type 1 people, type 2 people, and a list of empty nodes, or you can say empty cells. So we'll create 3 lists for that purpose. So I'll write type 1 node list. Is equal to, so this has to be a list, and what we can do here is n for n comma d. Now I'll explain what this means. G dot nodes data is equal to true. Okay, if the type of d is equal to 1. Okay, so let me tell you what I've done here. So when you print g dot nodes, you get only a list of nodes. But in case we have assigned an attribute to the nodes and still we write g dot nodes, still we get only the list of nodes. We don't get the type. Don't get the value of that attribute. In case you want the value of that attribute, you have to explicitly write data is equal to true. Okay, so when you write g dot nodes data is equal to true, you get n and d, where n is the node and d is the dictionary, which will contain the attribute and its value. So since we want to get the type of every node, we will write g dot nodes data is equal to true, and that will return us n comma d, where n is the node and d will give us the type. So we have written if d type is equal to 1. So if d type is equal to 1, the node will be of type 1. Sorry, please pardon my bad throat. Okay, so this is for type 1 node list. Similarly, we'll get the type 2 node list. We'll just copy paste. I'm sorry. Okay, so I'll write type 2 node list is equal to n for n comma d in g dot nodes that is equal to true if d type is equal to 2. Right, so similarly we can get a list of empty nodes, so we can write empty cells is equal to, I'll just copy paste. Okay, where the type is equal to 0. So this should work. We can also verify. Let me try printing the type 1 node list. Type 1 node list. Let me check whether it works fine. So okay, yeah, so this is the list of nodes which are in type 1. Similarly, we can print the other lists as well. Let me just verify and then we'll continue. um, Empty cells. Okay, yeah, so it is giving all the three lists. We are going to make use of these lists, so I'm going to comment this because we don't need to print. Okay, now what we can do is, now that we have assigned a type to every node, so we have two different kinds of people in our network. It'll be nice if we represent them with a different color, so that it's it's easy to visualize the kind of people that are present in a given cell. So let me create a function for that. I'll create a function, say display graph. So I'm just going to decorate the graph here. It's up to you how much you want to do here, how much you want to how you want to display, how much you want to decorate. It's up to you. You can skip some of the steps here if you want. Okay. Okay, so what I want is type 1 nodes should be displayed in say green color, type 2 nodes should be displayed in say red color, and empty cells should be say displayed in white color. So the function that we'll use is nx.draw network x nodes, where we can specify a list of nodes that should be displayed by a given color. So what we can do is nx.draw network x nodes. The parameters will be g, and this pos parameter that we passed already. And what else do we want? We want the node color, so I'll write node color is equal to green. I want it to be green. And then what should be the nodes for which we want to, as for whom we want to assign the green color. So I'll write node list is equal to type 1 node list, right? I'm going to copy uh, the next kind of nodes we want in red color. So I'll write nodes are uh, I want in red color, and then type 2. We are doing this all this here because it'll be nice to visualize the kind of transitions that take place. So although this is an optional step, it'll help us to visualize the things. Okay, I'll just go. Yeah, so we want empty cells here. I'll write empty cells, and I want white here. Okay, so now we have drawn the nodes, but the edges haven't been drawn, so we have to draw the edges. So we'll write nx dot draw network x edges, and there again the two parameters will pass, g and pos, the positioning. Since we are manually drawing the nodes and edges, labels will not come. So again we have to manually draw the labels as well. So we write nx dot draw network x labels, and again I think we used it already. So yeah, this one we can just copy this. Okay, this should work. And anything that we skipped, let's see. Okay, plt dot show. Okay, so now we have to call this function. Let me put this function on the top so that we can call it. So I'll cut it from here and I'll write it here. This is because we want to make use of labels. So I want to define the labels dictionary before I declare this function. Okay, so I'll call this function here. I write display graph g. Let me execute it. Okay, this is the graph that we initially displayed. This is the graph that now we are displaying, which looks quite better, and we are able to see which nodes belong to which type. So it looks pretty good. Okay. If you want, you can change the font size, you can change the node size, so that all you can play around. Okay. Okay, so what is the next step? We have the network, we have the people. The next step is to identify the people who are unsatisfied. Now, how do we find which people are unsatisfied? We should be able to know for a given node which are its neighbor, right? Only then we will be able to you know uh, tell whether this node is satisfied or unsatisfied. Now, in order to be able to know which are the neighbors of a given node, we should know whether the node is an internal node or is it a boundary node. So that we have to find out. So for that matter, it will be helpful if we create a list of boundary nodes as well as a list of internal nodes. So maybe we can create a function for that to get the list of boundary nodes. So what we can write is get boundary nodes. Let's pass the graph here. Um, boundary nodes list is equal to this. So basically we are going to put all the nodes which are lying in the boundary into this list through this function, which is get boundary nodes. Let's create this function. Let's see how we can do that. So I'll create this function here. Okay. Now, how do we do this? We should know which nodes are boundary nodes. If you remember the kind of grid that we were getting, you will know that the nodes which have either u or v, if uv is the node, the nodes which have either u as 0 or v as 0 is a boundary node. Also, the nodes which have either u as n minus 1 or v as n minus 1, they are also boundary nodes. So you can check the grid and see how it comes out to be. So let's write this function. Let's create a list which we will be returning. So I'll write boundary nodes list is equal to empty. So I'll write for u comma v. What else is there? D, which is the type. Okay, we can actually skip the type here because we don't need this. Okay, let's see. In g dot nodes, data is equal to 2. So what I was saying was data is not needed for this particular step, so we can skip that as well, and we can keep that as well. So I'm choosing to keep it just like that. Now, as I told you, if u is equal to 0 or u is equal to n minus 1 or v is equal to 0 or v is equal to n minus 1, then the node is a boundary node. So what we'll do is boundary nodes list dot append. We're going to append uv there. Yeah, this should work. Let me print also just to cross check whether things are fine or not. So let's print this. Whenever a node is appended to the list, that will be displayed. So once that is done, we are going to return this list. Okay. Okay, so we have already called this function. Yes. Let's execute and see. Before that, let me remove this displaying of the graph because now we have created a function and we are getting a better visualization. So I've commented it. Okay. So this is the graph. I'm closing it. Yeah, so we are getting things working fine. These are the nodes which are appended to the list. Okay. Now the second step is to get the list of internal nodes, right? So what we can do is if we subtract the boundary nodes from the total nodes, obviously whatever remains is the list of internal nodes. So what we can do is I'll create a list for internal nodes. Internal nodes list is equal to, now what is this? I told you this technique. If you want to subtract one list from the other, you can use this set function. So I'm going to convert a list of all the nodes into a set. So I'll write g dot nodes, uh, yeah, minus set, what should I write, boundary nodes list. Yeah, okay, this should work. So let me try printing these two lists just to cross check. So I'll write print boundary nodes list and print internal nodes list. um, yeah, let me comment that appending so that we get only what we want to print. Where is that? Yeah, in this function, uh, I'm going to comment this. Okay, let's check. Yeah, so we're getting two lists here. First list is boundary node list and second list is internal nodes. So we are doing well. Okay, so now we have a list of boundary nodes, internal nodes. What's the next step? The next step is to identify the unsatisfied nodes and then moving them to a new location. We'll do that in the next part of the video.